Hi dears, good morning. Welcome to Unique World Education YouTube channel. Today we are discussing some topics related to grade 11 again. This is the chapter functions for grade 11 students. And here we are discussing some important functions and the graph, domain, range and codomain. So let's do the functions. So first of all, we know that just the constant function. So mostly we are denoting with C as a constant. Then we can define the function f of x equal to C. So mostly we can reduce these words by using the mathematics notation. That means the function is from set of all real number to set of all real numbers defined by f of x equal to C, comma C belongs to a real number, because we are discussing real valued functions. And for all, we can use the notation for all x belongs to R. So mathematical notation, we can just reduce the words by saying f from R to R. So it's called constant function. So clearly the domain is set of all real numbers. There is no confusion. Domain is set of all real numbers. And the range, because if you are substituting any value for x, we'll get the range or we'll get the value. The function value should be C. f of 2 is C. f of 3 is C, because that means it's constant. For example, if you are considering f of minus 3, it is C. Or if you are just drawing the table to draw the graph of this function, if you are drawing the table like this, this is the x value, here we have y value. Mostly we are considering minus 3 to 3. So minus 2, minus 1, 0, 1, 2 and 3. So what is the function value? Here the function is constant function. So in any case we'll get C, 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 C again C, again C, C, because this is a constant function. This is independent of x. Whatever the value for x, we will get the function value should be C. So that's why we can draw the graph x-axis and y-axis. So clearly it's a straight line parallel to x-axis passing through 0, C. Here and just consider C is a positive number, that's why it is in the upper part. Okay, so next function, identity function. We know that it's very simple. X is maps to x itself, 2 is maps to 2, 3 is maps to 3, 0 is maps to 0. That is called identity function. So clearly it is, obviously we know that the domain should be set of all real numbers, because we can substitute any value for x. We will get the function value 2, or f of 3 will be 3. Okay, so there is no confusion, I think. So the range is set of all real numbers and the domain is also set of all real numbers. So clearly we have discussed the same notations we can use here for identity functions too. F from the domain, this is the domain R, this is the codomain, the second set is the codomain, defined by f of x equal to x for all x belongs to set of all real numbers. Now we can draw the graph. So clearly if you are drawing the table, it will be like this. identity function x value and y value. We are starting from -3, -2, -1, 0, 1, 2 and 3, because the identity function, that's enough. -3 is maps to -3. It is identity function. -2, -2, -1, 0, 1, 2. So clearly we will get a straight line passing through 0, 0. Passing through 0, 0. Look at here. The angle should be 45. 45 degree. Because this is exact. X value and y values are equal. That's why we will get the angle should be 45 degree for f equal to x. Okay. So next important one, modulus function. Modulus we are denoting with mod x. Here we know that the definition of mod x is x when x is positive minus x if x is negative. For example, we can consider the modulus of -2. What is the modulus of -2? We know that it is 2. But how we can define? That means -2 is a negative number. So you want to multiply with a negative. So negative of -2 is +2. And another example, modulus of positive 4 is a positive. So just write the same number 4. That's why we have explained the modulus function as x when x is positive or 0. Modulus of 0, it is 0. Okay, so this is the definition of modulus function. So it's called modulus function, and the graph, again, I know that it's very simple to draw the table for modulus function. We are considering x values, y values, -3, -2, -1, 0, 1, 2 and 3. -3, modulus of -3, it is 3. Modulus of -2, it is 2. Because modulus means find the absolute value or find the positive value. It is 1, 0, 1, 2, 3. It is like an identity here from right side. From right side of 0, it is like an identity function. So clearly we will get the right side of 0 just like an identity function. But on the left side, it is a mirror image of this identity function. Okay, identity function is going like this, but it's just a mirror image, it's a reflection. Okay, so this is the graph for modulus function. So clearly look at here, the domain and range. What's here? The domain. For any value of x, we can define this function. So domain is set of all real numbers. Domain is set of all real numbers. What's the range? Think about that. What is the range? Range means y values. Values of y or the values of image. Look at here. These are the values of y. There is no graph in the negative part. So clearly we can find the domain and range as domain is set of all real numbers. Range is 0 to infinity. That means positive values. Positive values of y includes 0. Okay, now we are denoting the modulus as modulus x. These are some definition. Okay, modulus x means maximum of x comma minus x, and also we know that modulus of minus x equal to modulus of x. Both are same. If you find the modulus of minus x, it is equal to modulus x, and it is called triangle inequality. Modulus of x plus or minus y is always less than or equal to modulus x plus modulus y. These are some properties or remarks or some results related to modulus x, the function f of x equal to modulus x. Next one, reciprocal function. Reciprocal means 1 by. So f of x equal to 1 by x. So clearly it is not defined in every real value for x. We know that this is 1 by x. So clearly 1 by x is not defined when x equal to 0. What will happen? When x equal to 0, it will be 1 by 0. Not defined. Not defined means we are denoting with the symbol infinity. This means not equal to a number, it is not defined. So clearly, can you guess the domain of this function? It is not defined when x equal to 0. So surely the domain, we want to eliminate the 0 because at x equal to 0 the function is not defined. That's why domain of f is equal to r minus set 0. Set 0 means we are eliminating the element 0 from the real number. So 1 by x, now we have find the range. That means we are considering y is equal to 1 by x. So clearly we will get x equal to 1 by y again. X equal to 1 by y. It is not defined when the denominator is equal to 0. So we want to write y is never 0. Y is not equal to 0. What's y? Set of all y values is the range. So we can define the range. So we can define the range as r minus set 0. So domain and range are here, both are same. R minus set 0. So next we can draw the graph. It will be like this because x never be 0, y never be 0. So the graph is like this shape. Actually the graph is like this. It is approximately, okay, it is not touching the y-axis or not touching the x-axis. It is nearest to x-axis, nearest to y-axis. It will be going like this. Okay. This point is 1, 1 because here we have negative 1. So this point will be minus 1, minus 1. And this point, obviously, this is 1, this is 1. So this point will be 1, 1. This is a rough sketch of this graph M1 by x. So next one we are discussing the function signum function. Now we are discussing signum function. The function defined by f of x equal to, signum function means, we have mod x by x when x is not equal to 0 and 0 when x is equal to 0. Signum function. And again look at here, if you want we can define mod x again. That means we know that mod x equal to, if x is negative we can write minus x if x is negative. If x is positive we want to write the x itself if x is positive or equal to 0. So in the signum function we have mod x by x. Signum function we have mod x by x. So mod x we can split the function into two, minus x and x. So mod x by x we want to divide by x. So minus x by x, x by x. Here x is less than 0, here x is positive. We cannot include 0 because in this signum function x equal to 0 the function is 0. Okay, so what is minus x by x? We can cancel these two x, we'll get minus 1. We can cancel here, we'll get 1. So if x is less than 0 it is negative 1. If x is positive it is 1. If x is 0, the function value is 0. So this is the definition, or this is the definition of signum function. Here we can define the signum function like f of x equal to -1, 0, 1. So clearly it is obvious the function value is the range. Function value is the range. So in the range we have only 3 elements, -1, 0, 1. The y values are the range. So it's called signum function. So clearly f of x is equal to 1 when x is positive, 0 when x equal to 0, and -1 when x is less than 0. So we can find the graph of signum function. If x is 0, the function value is 0. If x is positive, the function value is 1. If x is negative, the function value is -1. So clearly we can draw the graph. If x is negative, negative means left side of 0. Negative, we have the function value -1. It's a constant on the left side. In the right side too, it is constant. So this is the graph for signum function. So clearly, domain is set of all real numbers. The range, obviously, the values of y. So -1, 0, 1. Is it continuous? Just an extra. It is not continuous because we know that from here this function is jumping to here and to here. Okay, so it is not continuous. Okay, so it is not a part of this graph. I'm just explaining, I'm just connecting with continuity. So next one, square root function is very important. Square root function, because mostly the exams is related to the square root. Most schools are asking these questions. Find the domain and range of a function which includes the square root. So the function f of x equal to plus root x is called square root function. Since negative square root, so therefore domain should be 0 to infinity. Surely you have a doubt in this part. So consider the function is defined by f from, we want to find the domain here, to the codomain. So we can consider codomain as set of all real numbers because this is a real valued function. But the problem is that how we can find the domain? We want to find the domain here. So for that, we are considering the function. Function is f of x is equal to square root of x. It's a real function or real valued functions. So clearly, square root of a negative number, it is not a real number. We have studied from grade 10 or grade 9 onwards we are studying. We cannot find the square root of a negative number. So we want to define this function by x should be, that means inside the square root should be positive or 0. So x means the domain, the values of x is the domain. So domain should be 0 to infinity, positive numbers including 0. So x is belongs to positive real numbers including 0. The same focus, the same concept we can use for the range, because we know that we are substituting y is equal to square root of x. So by taking the squares on both sides, we will get y square equal to x. So clearly we can define x equal to plus or minus square root of y. The same square root, the same concept, the same real number. So the same range, we will get 0 to infinity. The values of y is the range, the values of x is the domain. Okay, so we can construct the graph root x. So it is 0 and a part like this. Actually, it is not ending, it is going like this. Okay, so a rough figure for f of x equal to root x. Is it clear? Domain, range and codomain. And this is the theory part, how we can find the domain and the range. So f of x equal to plus root x. What will happen if it is minus root x? Because there is a doubt why we are using plus root x. What will happen if it is minus root x? Minus root x means this portion. You will get minus root x. Okay. So next we can discuss the next function. Next one, greatest integer function. The name itself is like the definition. We are denoting with this symbol, greatest integer function. First of all, we can define the theoretical part. Okay, it will be confused because we are using some inequalities. We can consider some examples. What's the definition? If f of x is equal to n, if n is less than or equal to x less than n plus 1. For example, f of 2. 2 is an integer, am I right? So clearly we will get f of 2 is equal to 2. F of minus 3. Minus 3 is an integer, so minus 3, the image of minus 3 is minus 3. F of 0. 0 is an integer, so clearly f of 0 is equal to 0. Now the problem is that what will happen if for f of 1.5? Clearly 1.5 is not an integer. So what will be the function value of 1.5? Look at the definition. F of x equal to n if n is less than or equal to x less than or equal to n plus 1. So 1.5, this is the x. It is in between 1 and 2. Am I right? So clearly 1.5 is in between 1 and 2. Look at the definition. In between n and n plus 1, then n is the function value. In between n and n plus 1, then n is the function value. So clearly 1.5, so 1 is the function value. Okay, so the domain, set of all real numbers. There is no confusion, set of all real numbers. But what about the range? Range means the function value should be an integer, 2, minus 3, 0, 1. In any case, the function value or the y value should be an integer. So the range of the function should be an integer. Okay, so again you have a confusion with negative. For example, f of negative 2.3. Negative 2.3. So clearly we can write the inequality. Negative 2.3 is in between negative 2 and negative 3. Did you get that? If you are drawing the straight lines or the real number system, here we have negative 2, here we have negative 3, here we have negative 1. So clearly in between minus 2 and minus 3 we will get minus 2.3. So f of minus 2.3, the smallest number, it will be minus 3. That's the difference if you are considering the negative parts. It is not minus 2. F of minus 2.3 is minus 3. Okay, now we can draw the graph of greatest integer functions. We can draw the graph 0. And how we can draw the table before that? Before the graph, we can draw the table. It will be interesting. The table should be interesting. The table x value, y value, we are considering x values and y values. Minus 3, mostly we are taking minus 3 to 3, minus 2, minus 1, 0, 1, 2 and 3. Just arbitrary we are selecting this one. So f of minus 3 should be minus 3. F of minus 2 should be minus 2. But here we have a confusion. So I am considering another table for some points. Then only it will be clear. X value, y value. I am considering a point in between minus 3 and minus 2. Minus 2.5. What is the y value? It is minus 3. And again minus 1.5. Between minus 2 and minus 1, it is minus 2. And again I am considering 2.34. It is in between 2 and 3, so it is 2. Okay, do not confuse. So clearly 0 to 1 the function value is 0. 1 to 2 it is 2. It is like that. It's like a step function. Okay, it's like a step function. Look at the graph. It's like a step. So the graph is called step function, the greatest integer function. That's the name. Look at here, the greatest integer function or step function. The graph is like a step. Okay, so next one, we can consider some properties of greatest integer functions. So this is the definition is the first property, because n is less than or equal to x, less than n plus 1, then greatest integer of x should be n, where n belongs to z. N means set of all integers. Second one, x minus 1 less than the greatest integer function x, it is less than or equal to x less than greatest integer x plus 1. Okay, greatest integer means this is a natural, this is an integer. It's also an integer. Okay, but it's a possibility to get a real number, x minus 1. This is also as a possibility to get a real number. But the greatest integer x should be a real number, and greatest integer x plus 1 should be a real number. Okay, so next one, these are some properties or some results related to the greatest integer functions. M is less than or equal to greatest integer function x less than n if and only if. If and only if means if the first statement is satisfying, then the second one is also satisfying. And if and only if double implication is there, so we can write if the second statement is satisfying, then the first one. So we can also read the statement like this: if m is less than or equal to x less than or equal to n plus 1, then the first one, m is less than or equal to greatest integer x is less than or equal to n. Okay, so I think we are discussing the greatest integer function. I know that these are some results. The fourth one, some confusions will be there because this is Pakka theory part. We are not discussing any problems. Okay, so these are fourth one. Oh, look at the fourth one. Greatest integer of x plus n equal to greatest integer x. X is a real number, n is integer. So greatest integer x plus n, and the interesting one is the fifth one. Interesting one. Greatest integer of x plus greatest integer of minus x. We just guess the answer. It is equal to the same x, but we are taking positive and negative, or the negative or positive and positive. What will be the answer? Yes, maybe we'll get a 0. because if both are integers, for example, we have 2 and minus 2. Here this is 2, here this is minus 2. If both are integers, surely we'll get 0. What will happen if not an integer? X is a real number, it will be minus 1. If x is a real number, that means f is not an integer but a real number. Okay, so I think today that's enough. Okay, thank you. We can discuss some more concepts and questions related to this chapter, functions. Okay, so I'm stopping and thank you for watching this video. Okay, bye.